Okay, we're going to talk about transformations of graphing sine and cosine functions. Our goal is to be able to graph them with those transformations by the end of class, say tomorrow. So to begin, we've done transformations many times with many different functions, and the concepts will remain the same. So think about our quadratic. If I had our most basic quadratic, y equals x squared, if I had this new equation, this graph is a transformation of this graph. Do you remember what they mean? What do the numbers mean in terms of how the graph is transformed? Let's recap. Notice the negative inside of the function is inside the bracket, outside of the function is outside the bracket, right? Anything outside this operation which is being squared. So the negative is outside, it's a vertical reflection. And we've talked about that being a reflection in the x-axis. The 3 means, since it's bigger than 1, it's a stretch. It's a vertical stretch. The subtract 4 inside the bracket, right? Since it's inside the bracket, it's that opposite thinking. Now, since it's inside the bracket and it's subtracting, this is a shift. And it's a shift right by 4. And outside the bracket here, we're going to add 5. That means we're going to have a shift up by 5. Okay, so those are kind of basic transformations that we've discussed before apply with, say, these new functions, sine and cosine functions. But first we need, like we've done before, when we graph it, we graph the most basic function by looking at key points, and then we graph we shift by adjusting the table to graph the new functions. So in this video, I'm just going to discuss the key points that we should use for both sine x and cosine x. Make sure you record them and bring them to class. Okay, so key points for sine x. Notice, if on your calculator, sine x started at, like, sine of 0 was 0. Now think about that Desmos sketch we did. Now if you remember that, this Desmos sketch kind of looks like this. It goes up, comes down, it comes back up. That's sine x right there. It kind of goes up, comes back down, comes back up, and it does that over and over and over again. So sine of 0 was 0. And on our calculator, if you break it out, you can go along with this with me. It reached a maximum up here, and then it comes back down. So we know the basic shape is this nice kind of wave. So we don't need to put a whole bunch of points in. We're just going to pick 5, like we've picked for 5 for all of our other points. But so no, it goes up and it reaches a maximum, and that's probably a key point to include so that we know where the maximum is. And that maximum occurs at 90. So when you put sine of 90 on your calculator, you got 1. And our Desmos graph will also show that. And then it comes down and has an x-intercept right here. We should probably include that x-intercept, and that is at 180 degrees. So sine of 180 was back to 0. And then it went down to a maximum down here, and that minimum down here, and that minimum was -1. And that occurred at 270 degrees. And then it comes right back up to being the x-axis and starting all over again after 360. So these are the 5 key points we're going to use to sketch. So 0, 0, 91, 180, 0, 270, -1, 360, 0. Notice it's pretty easy to sketch those. If you have an axis, you got 1, you got -1. If you're going to go over, you could easily plot that, it's going to do 1 cycle after 360. Half of that is 180. In here is 90. In here is 270. And so it's going to start here and kind of reach a maximum here, have an x-intercept here, reach a minimum there, come back there. Make sure you just kind of have this nice wave to reach that. And it does it again and again and again. So record these points, bring them with you next class so that we can go over and sketch transformation of these. Don't forget, we'll do a quiz underneath about writing equations or recognizing equations with the transformations in them. Okay, let's look at cosine. I'm going to get rid of this. We don't need that. We'll do that in class. Let's just go over the basic points for cosine. Let me sketch it quick for you from your graph on the weekend or on Thursday night from Desmos. It looks very similar to sine, except this time it started up high, and it was maxed up there, and it came down, and min, and then came back to a max. And it did that over and over and over again. Okay, so this time, when x is 0, cosine of 0 was 1 on your calculator. And then we got a whole bunch of points that were decreasing, but then the next key point we should probably pick is the x-intercept. And that occurs at 90. And then if you continue with your calculator, you're going to say at 180, you get that minimum. So cosine of 180 was -1. And if you continue that back up to the next intercept, that occurs at 270 on your calculator. And then you come back to the beginning, which was after a full rotation at 360. You're back to 1. So notice the x values of cosine, the key values we're going to use are the exact same key values as sine. It's just the graph is slightly different. Okay, so record these and bring them to class so that we can do some sketching.